Hello and welcome back to the Raspberry Pi coding channel. This is video 7 in Humans versus AI, and in this video we're going to show the game over player has won overlay on the screen, which we're currently missing. In the last video we introduced the energy grid and the ability for players to collect energy and basically win the game, but there's no feedback to the player that they have won, so we're going to introduce that screen. We also have an issue where we can select the same color multiple times for players, and that's not great, so we need to fix that logic as well. So a nice quick one just to correct a couple of oversights, shall we say, and after that we'll be looking at refactoring, and then after that we'll be getting into the machine learning. I have a Patreon account if you'd like to contribute to my work. I'd very much appreciate it if you do, and if you do, you can access the code that you see here in the videos and early access to the videos for a while at least. Okay, let's get over to our IDE, my IDE. So getting straight on with it then, let's talk about how we're going to change the problem we have with the color. We'll start there. So at the moment, if we scroll down to where the color is assigned, which is done as part of the player class because color is a player property, we'll see here that the player color property is defined on instantiation of the player here using the assign color method. So if we look at the assign color method, it has a simple bit of logic which says the color is green if you're ID 1, and this is because I want to make sure that it's identifiable easily who the human player is. Otherwise, pick a random color. The random color method is directly beneath it. And what that's doing is it's simply picking one of 6 arcade colors, which are quite separate on the color palette. But the problem with this is each player picks randomly from that set, which is a problem in that this 2 players or 3 players or 4 players or all the players theoretically could have the same color. So we need to rectify that. So let's have a look at how we rectify that. So going on to the new code then, file 6, the first thing is we've got a color pool, which is giving us a series of colors that are reasonably separated in the color spectrum. Some of them are quite close, I have to say. So I might change this again in the future, but the point is you've got a pool, an array of colors defined in RGB space. And then at the end of defining that color pool, it is randomized so that with every new game, or at least every new run of the code in this case, the colors are going to be different. So that's the first thing, color pool. Now let's scroll down to the player class again, where the color is assigned to see what's changed. So back down to assign color again that we just looked at. The same logic is in place. The same use of the random color method is in place, but random color is now actually simpler. Random color simply assigns a color based on the color pool array. That's all it does. It uses the modulus operator here so that if we've got more players than we have colors, it'll go round again effectively and start and go through the list again. And it uses, I should mention this first really, it uses the ID of the player to define what row or what index from color pool to pick. So that's really important. That's really the point of this, is that because each player ID is unique, it's an integer, it means that the same color will not be picked twice. It's no longer random in that sense. Each player will have a unique color because it uses the ID. And like I said, the modulus operator is used so that if we have too many IDs, it'll go back round and start again in the array. So that's now how we define color. And if we have a look, if I pick, we certainly can't get the same color twice. But if I have, say, how many players, number of players 10, if I run this now, execute the Python code, it'll get compiled and run. And there we go. Although we've got some colors that are quite similar, we'll see that no 2 colors are the same. So that has been achieved. Okay, that's the first part. The second part, excuse me, is that we need an end game screen. So going back then to where the game is terminated, which is in the main game app class in the on update method, we terminate the game here at the top when game over state equals true. If you remember, game over state is set true down here at the bottom of the on update method when a player's energy is equal to or exceeds the energy to win. So it's quite simple logic, and that's how we terminate the game. But at the moment, what we're doing is we're basically returning from the onUpdate method, which means we don't receive any more state updates for the game. It does carry on rendering though, because that method of onDraw carries on. And so the game effectively pauses without any human interaction, which we'll solve in a later video where we actually do exit the game properly. But for now, this is sufficient. But what we are missing is feedback to the player that the game has been won. So we're going to change that. So first thing we're going to do, before I go on to number 6, is to say that this is going to be taken out of onUpdate. although, sorry, not all of this, this print is going to be taken out of onUpdate. We're no longer going to report back the game is over. Here, we're going to do that in the draw method, which is going to draw a message on the screen. Therefore, we're going to save the winner of the game in its own object. And if you remember, for those with good memories, in the previous video, we did have a winner object as a game state, which we haven't yet used. We're now going to use that. So let's go and have a look again at the at the onUpdate class. So in here now, you'll see we've assigned it. That's what's changed. This is the same code in onUpdate for terminating the game with game over, but we've added this line. We're going to record who's won. We're setting the player variable to, the winner variable to the player who has won, based on how many energy points they've collected. Hope that's clear. So going then back up to the onDraw method here, if we scroll down to the bottom of it, we'll see that we've got the content we now want to display on the screen. This should eventually be in its own method, but for now, this is fine for explaining what's going on. So if game over is true, otherwise this will get ignored, this code is run. We get the center position of the screen because we want to render the text in the middle. Then we use Arcade's draw text method 3 times to draw 3 lines of text. The first line of text is game over at position X, Y plus 50. So we're going up from the middle. It's going to be white. Then we draw the word player 1. In my case, would be player 1 because it's winner ID. Player 1 at the center of the screen in the player's color, the winner's color, because winner is a player object. So that's then player 1, say it's going to be green. And then the last line is wins, which is minus 50 pixels. And is going to be white. So plus 50, centered, minus 50. So 3 lines of text, one on top of each other, centered on the screen. And that's it. So if I play this, we should be able to conclude this video quite quickly. So there we go. We've got loads of players, all random colors that cannot be duplicated. And if we collect an energy point, because I've set it to just 1, we see game over, player 1 wins. Exactly what we need to see. Okay, that brings an end to this video nice and quickly. I hope you found it useful. In the next video, we're going to be looking at refactoring this code because you'll notice it's getting quite difficult to navigate. And it's getting a bit long. So we're going to start pulling out the code into separate files to make it easier to work with. But also because when we start working with the machine learning piece, we want to have it all separated out for convenience. I want to separate game logic from things like the player class. I want to make sure that the machine learning training loop is separate as well. And as we're going to start working with separate files for the machine learning, it's important that the game logic is also split out accordingly. So that's what we're going to look at in the next video. Thank you for being on this journey with me, and I'll see you there.